Hello, good afternoon, everybody, and welcome to the ntop webinar. Today, we want to give you a quick update to what has happened in the past months and give you an idea of the features that we plan to implement and to deliver in the next release. Thank you very much for being here. The main highlights include 4 talks, very short. In essence, we'll be talking soon about OT monitoring and flow aggregation. That is a new topic that will soon be part of the ntop product in the next table. And we also talk about REST APIs. Later, we have some talks about traffic rules, because in addition to behavioral rules that you already know, it is now possible to have rules that are more, let's say, static and based on thresholds. As well, traffic analysis based on the server port to understand in a network what is happening, what are the servers that are delivering services to other hosts, and how they are used. And then Matteo will highlight the new user interface. So we have made some changes, in particular to charts, and this is a hot new topic that we want to show you today. And then for the first time in ntop NG, we are talking about live and inactive monitoring. It means that until now, ntop NG was displaying you traffic of hosts that are alive. So in essence, that are producing traffic. Whereas now we are also giving you an idea of hosts that have been active some time ago and that are no longer active. This is the first step toward asset management that is a hot new feature of the new release. And then finally, Alfredo will give an overview of the smart recording feature that we have introduced in ntop and of a new type of extension that we have coded in PF-Ring that allows us to move Suricata and Zik, but any other application in essence, at 100 gigabit. This leveraging on ntop NG behavioral analysis that enable this type of new features. And then finally, Alfredo will talk about cloud licenses. That is something new today. Before starting, I want to say that this year is the 25th anniversary of ntop. It means that 25 years ago, I started coding the initial ntop and original ntop application. And today we want to celebrate this with a conference. The conference will take place in Italy, in Pisa, the hometown where everything started. And it will happen in September. As usual, we want to do 1 day of training and 1 day of conference. Until the end of this month, June, okay, we have a call for paper open. So I put the URL here on the slide. And I would like some of you to talk about ntop. So it means that, if you want to talk about features or things that, you have in mind, give us idea, that would be great. Otherwise, another possibility is to talk about ntop in your enterprise, in your company, in your network. Just to tell us, how you are using our tools and to advertise, in essence, those tools in the daily life. We'll be talking about ntop NG, NDPI, ntop, and any other topic that has to do with cybersecurity and network traffic monitoring and visibility. This is a very important date for us, and we would like you to participate. You will have external speakers coming from other companies that are using ntop NG. So we welcome you if you have time to talk at this conference. Now let's talk about the first topic, SCADA and OT monitoring. It is probably not something super popular here, but we want to tell you about that. As you know, SCADA and OT monitoring is part of ntop NG since some time. So in November 2020, I added the first part of this talk. So in essence, the IEC 104, that is a protocol used mostly in power plants. This protocol allows through ntop NG to monitor traffic of power plants. And last year, the ntop conference, Martin Choi gave us an idea of how to use our tools for monitoring critical infrastructures. We have implemented this in ntop NG as open source extension, so it means that everyone can use it. And this year we'll be talking about another protocol, probably more popular than IEC 104. And the idea is to continue expanding ntop NG so that we are able to cover, the most relevant protocols in this area, so that the people can use ntop ng not just for standard monitoring, but also for this type of tasks. Our approach is a little bit different from what other companies are doing that are doing something very vertical, because we are coming from network traffic monitoring. So our approach is very generic in the sense that we are able to implement those features that are relevant for everybody, not just in standard internet monitoring, but also in OT. So first of all, active and passive asset discovery and management. As I said, Matteo will now give you an idea later today of those hosts that have disappeared. So in essence, you have an idea of the hosts that are living on your network, what type of activities they are doing, what type of services they provide and they have. This is very important. Of course, we have traffic monitoring. That is something we have done for a very long time. And we have behavioral traffic analysis. So it means that we analyze the behavior of the network of the traffic and then decide whether a certain alert has been triggered. We have anomaly vulnerability detection. And of course, we are able to interact with tools for threat intelligence to be a feed for those tools. This is something we call generic monitoring. In OT, we have implemented the extension in the usual way. Basically, we have done it in several steps. The first step is to implement support of the protocols inside the NDPI. So it means that the NDPI, first of all, has to be able to recognize the protocols that we'll later be using. Okay? So as you can see, at the moment, we have 6 protocols implemented in NDPI, and two of which are supported also by ntop ng and nprobe. In nprobe, we have created a plugin called Modbus TCP that is the protocol that I will describe today. It's a very popular protocol. Modbus was originally created for serial communications, and over the years, because the serial ports are no longer so popular, it is running on top of TCP. It is used in many fields. So it is very generic, very popular protocol in the OT field. And nprobe is able to generate logs of activities. And of course, the third step is extend ntop ng. That is probably the tool that you know. In ntop ng, so we have done some extensions that are able to detect things that are somehow special, okay, in particular in this domain. So first of all, unusual error messages or unsupported function calls. So namely, when you want to use the protocol for things that are not supposed to be used, okay? And this is the very basic one. And then we have, behavioral analysis, for instance, function calls that have not been used before. So in essence, those activities that a certain host has not done in the past that is doing now, or in an unexpected transition. You know that in OT monitoring, when you have certain activities, it corresponds to a physical action. So you open a gate, you close a gate. So this type of transition that didn't happen before, so the gate is open, you want to open it again, that is very unusual. Okay, are recorded and they trigger an alert. Or changes in frequency and periodicity. So namely when something happens and it looks good, but it happens at a different pace. Okay, like if you do, if you have a breakfast in the evening, that's something very strange, but doing breakfast in the morning is something normal for us. And as usual, we have implemented behavioral checks. We have here depicted those for IC104 and for Modbus. So as you can see, we have the invalid transition, too many exceptions for when there is something wrong for that exceeds a certain threshold, or when we have unexpected code. So it means that when a certain host is doing activities that are not supposed to happen. And of course, as I said before, we have the transition monitoring. So in essence, we monitor the state of a device and we check if the device state is changing over time to a state that was not expected to be seen, because according to the past, this was not possible. And we implemented this through behavioral learning. Okay, so learning, it's a very hot topic today. So we have implemented it here. So in essence, it's possible to specify for every flow, so for every communication, because every device has a different life cycle, the type of activities that we expect to see. So we say we observe this device for 6 hours, so let's say, and whatever this device does for us is normal. And after that period of time, then we consider, a transition, or let's say activities that does not close to what we have seen in the past as exception. And this can be triggered in an alert. And as usual, we trigger alerts, okay, that contains a context. So it means the description that contains, okay, we have reported this problem. So in this case, so we see a function of write that was detected. So it means that you're reading from this device many times and everything looks good. At some point, you want to write to this device. It's unexpected because for this particular communication, we didn't expect to see write, or for this firmware update. So these are the typical examples. This, as I said, is probably something very specific that not all of you appreciate, but so we want to say that we are expanding, okay, to, let's say, non-internet monitoring. That is something that you know for a long time. The second topic I want to discuss that is more general is aggregated flows. As you know, in ntop when you started with the ClickHouse, it's possible to dump historical flow to the database. And this is something very important because it allows you to have a context of alerts, okay, or to understand past activities of a host and allow you to do the read down. You can do it from inside ntop, or you can connect external tools such as Grafana to ntop or directly to the ClickHouse database in order to extract this information and to understand what is happening. Also, we have integrated this with N2Disk. Okay, so if you have the bundle license, or if in general you are able to run N2Disk in addition to ntop, it is possible to correlate an alert with a flow with packets that have created the alert. This is something that is there since a long time. The main problem of this approach is that historical flow can be several millions a day, in particular if you have a large network, and then exhaust the disk space. And now, if you ask yourself, why do you need raw flows? Why do you need these raw activities? It is because you want to drill down. You want to go back in time. ClickHouse, it is very efficient, and we have tried to optimize the way we dump data into the database. So therefore, today, we're able to dump data with less than 60 bytes per flow. So even if you have millions, it will not take a lot of space. But the cardinality of events are very high. So if you want to do an analysis, you usually do this analysis in the short term. So let's say the first few days or the first week. After 1 week, it is unlikely that you want to go back to that level of detail. So therefore, we have said to ourselves, instead of keeping those alerts or those flows just for a short period of time, we want to give the ability of people of aggregating them over time. So in case they want to do top X, or if they want to understand, for instance, the nature of an alert, even after 1 month or 2 months, this is possible. But we want to save disk space because otherwise, with high cardinality, the queries will be slow and you will be using a lot of disk space. So for this reason, we have implemented the aggregated flows. In essence, what happens is that we have added, as you see from the screen here, a new toggle button that allows you to move from historical records, raw, okay, as you know them today, to hourly flows. So it means that every hour we aggregate flows together that have the same triplet. So the same IP source, the same IP destination, the same destination port, and of course the same VLAN. So this means that if you have constant communication from hosts that are doing more or less the same communication over and over, in particular for repetitive protocols such as HTTP, those flows will be collapsed together. So in this case, you can see that the first flow here in the past hour has been issued 122,000 times. So instead of having 122,000 records, we have one record only. Of course, the aggregated flows are aggregated per hour, and you still have the raw flows. So it means that if you are saving the raw flows, let's say for 1 week, and you are within the first week, you can play with aggregated flows to have a quick reporting. But if at some point in time you want to go back to the raw flows, ntop allows you to jump to the original flows. It is not that the original flows are discarded. Okay, this is a very important message. Now, how do we aggregate flows? So we try to do it in a smart way. So in essence, we want to save disk space, but at the same time, we want to retain visibility. So this is a typical example of 1 hour on a service provider that is using our tool. As you can see, in the past hour, so he had many records, millions of records. Okay, so here we're talking about hundreds of thousands of records. And this is the main advantage. And we have flexible settings, as you can see. So it is possible to change and to adapt to our needs aggregated flows. So in essence, we aggregated flows based on the number. So we say, keep me at most, let's say, 10,000 or 100,000 or 1 million flows per hour, so not more than that. And at the same time, you can set a threshold saying, you have to discard the flows that are smaller than. So in particular, tiny flows, such as those of 1 kilobyte or less, can be discarded. Again, this is an option. It is not something that we write in stone, so it's possible for you to set in the preferences. And finally, you have to specify whether you want to keep flows that are related to alerts. So namely, in case of an alert, okay, so you can decide if you want to keep the flow that has triggered an alert, or if you want to say, even if this flow was not relevant, I want to keep it, okay, or say, okay, no, I want to keep only the big one. But what I want to say one more time is that we keep aggregated flows and raw flows, both at the same time. And you can decide which one to use. Of course, aggregated flows are less than raw flows, so it means that queries will be much faster than the other one. The last topic I want to tell you today is monitoring of Zoom in Teams. So today we are using Microsoft Teams, and this is a popular application. And we have heard from people that many times they are facing problems with this type of video communication simply because they try to use a lot of bandwidth because you want to have video, many participants, things like that. And people are somehow blind with respect to this type of traffic. So some of you have asked us to put a little bit of effort in this type of problems, and to create an extension to our tools that are able to analyze not just the traffic, but also to identify the type of traffic, if it's an audio or video stream, and the quality. And this is what I'll be talking today. As usual, as shown with you before, the first thing we have done, so we have enhanced NDPI, so that we have created various protocols, in particular for Teams. Teams is using the same protocol used by Skype, because Skype, I don't know if you're aware of it, it has been acquired by Microsoft some time ago. And also, those protocols are very aggressive. They try to pass through firewalls. So in case you want to reduce the bandwidth, or in case you want to drop a certain type of traffic, they switch to another protocol. So for instance, Teams is switching from standard UDP, as today, to TLS, so in case the firewall is close to this type of traffic. So the problem is not that simple, but we managed to solve it. Inside nprobe, so in case you want to do a remote monitor, so in case you want to monitor the traffic remotely, otherwise you can put ntop directly on the network. So we have added some extensions because, for instance, talking again about Teams, so you will see that the traffic will start as STAN, okay, encrypted STAN, and this STAN traffic at some point will turn into RTP, again with a specific version of Microsoft. So we have enhanced our tools so that it's possible to recognize this type of stream and report the data. Now, as you can see here in the right part of the screen, so for every flow, or here at the bottom, so we show not just the flow type, such as, of course, Microsoft Teams, but also the type of stream. So if it's an audio, screen sharing, and so on. So this gives you an idea of the bandwidth that you're using for a specific communication, so that you can keep an eye to what type of communication are using a lot of resources. So for instance, you can push your users not to use video if it's too expensive in terms of bandwidth. And the very last topic I want to say today is that if you want to use the latest dev version of ntop, and if you're a programmer or if you're using ntop embedded, so it means that your user will never see the ntop user interface, but will extract from ntop data, such as, for instance, we have some partnership with CheckMK, that is a popular company that is doing service monitoring. So they're using ntop as a server. So they're extracting data from ntop with a REST API. So now we have integrated inside ntop something called OpenAPI, so that is possible from the developer menu, okay, to go to the first entry REST API, so that you can directly play with the browser with ntop and issue requests that will go to ntop and that extract data. Again, this is just for developers, but if you're using ntop, it's very handy because it allows you to play directly with it without using external tools. And this is basically all I want to say today. I don't know if somebody has questions, but I would like you to listen to my colleagues first, and then we'll move to questions at the end of the session. Thank you. Next one on stage, please.
Yes. So, can you see my screen?
Yeah.
Okay. Hello, everyone. I'm Nicolo, and today I will talk about 3 new features of ntop ng: the SMP devices rules, the host and network interface rules, the server ports analysis page. And all of these features displayed on this presentation are available only from Enterprise license or superior. So starting from the SMP devices rules, monitoring several SMP devices in order to unveil changes and changing trends in traffic can be difficult. So SMP devices rules enables the creation of periodic checks for all or selected SMP device at a specific frequency, 5 minutes, 1 hour, or 1 day. The triggered rules will emit a threshold crossed alert when an SMP device exceeds up or down the specified threshold in packets, bytes, or interface errors. So in order to add new SMP devices rules, the user has first of all select the SMP device from the list of all SMP devices available, or select just star to perform checks on all of the SMP devices. And then the user has to select the SMP device port on interface field. And in case the device is a single one, it's possible to select star as interface to perform checks on all of the SMP ports of the selected device. After that, the user has to select the metric that can be bytes, packets, or errors. Then the check frequency, 5 minutes, 1 hour, or 1 day. And finally, he has to select the threshold, the rule threshold. And in case of bytes, it can be volume, throughput, or percentage. In case of packets, can be just percentage. And in case of errors, the threshold measurement type is an absolute value of the packets. The percentage means the increase or decrease in percentage compared to the last value analyzed. So, for example, if you select 5 minutes, the percentage is calculated between the actual value and the value of 5 minutes ago. So this slide shows the threshold crossed alert details in case of the SMP devices rule. So particularly, there are the SMP device IP, name, and interface, and also the description with the value that crossed the specific threshold of the rule. About host or network interface rules, same as SMP rules, but for hosts and interfaces. So frequency are always of 5 minutes, 1 hour, or 1 day. And the triggered rules will emit a threshold crossed alert when a host or a network interface, in this case, exceeds up or down the specified threshold, score, or specific application traffic. So now, in order to add host or network interface rules, first of all, the user has to select the rule type that can be host or interface. And in case of rule type host, the user has to indicate in the target field the localhost IP or just star. And as well as the SMP devices, all of the hosts are going to be monitored by the same rule. Otherwise, select network interface. Then select the metric, traffic score, etc. And select the check frequency, 5 minutes, 1 hour, or 1 day. And finally, select the rule threshold. And now in this slide is present the local traffic rules page with all of the details of the host or network interface rules enabled. Every entry in particularly has the actions menu with the edit and delete rule options to modify or delete a specific rule. Now I'm going to talk about the server ports analysis page. So monitoring available host services is not simple with live traffic view. So on the other hand, it is important to keep an eye on new or disappeared server port. And in order to enable it, start selecting a network protocol, then an application protocol, and the server port. So the page displays many server localhost details, including host IP, host name, MAC address, manufacturer, host total score, host total flows, and host total traffic. Finally, on this final slide, you can see an example of the server ports analysis page. In my case, I select the network protocol UDP, the application protocol DNS, and the server port 53. In my case, there's just one host, the gateway one. On the server port, you can note on the server port label, you can note is indicated the count of local hosts that are using that specific port. Next step of this page will make also the historical version of this page. So thank you, everyone. If there's any questions?
So thanks, Nicolò, for the presentation. Let me share the screen now.
Yeah.
So hello, everyone. You should be able to see my screen, right?
Yes, go ahead.
All right, great. So hello, everyone, and I'm Matteo, and like Luca introduced at the beginning of the webinar, I'm going to talk about again ntop, but I'm going to talk about behavior analysis, and what we introduced in the latest weeks for the first time in ntop, the possibility to see not just live traffic, but even not inactive traffic, let's say, inactive host in the specific case. But let's start with behavior analysis. In the latest ntop releases, what we've been trying to achieve is the possibility to not just show you information about host packets and flows that we see on the interface or network that is. But what we've been trying to achieve is the possibility to understand the traffic that those hosts, those interfaces were doing, and trying to understand if they're doing something wrong or not. So this time we introduced the possibility to, let's say, foresee the traffic a host or an interface is going to do in the future. What we used is an algorithm. It is not a machine learning, but it is a really good algorithm that is able to understand in the near future the traffic that a host or an interface is going to do by taking a look at the older traffic of that same host or interface. This is in order to understand if there is some problem with some host or interface, because think of this from another point of view. You are in an enclosed system. In an enclosed system where you have the same host doing a specific amount of traffic during the time. For example, you know that you have a server that it is doing an upload or a huge download during the night in a specific time frame. And you want to check if that specific amount of traffic is the same during the days, during the weeks. This is possible using this behavior analysis. And as you can see from the images, we have a value, a blue line inside the chart, a blue line that represents the actual value, the real value that ntop has seen as analyzed from that host or traffic or interface. And then you have two ranges, an upper and a lower bound. And obviously, what happens whenever that real traffic exceeds that lower and upper bound? If you enable we are going to trigger an alert. This is because that lower and upper bound are calculated by using that foreseen algorithm. Instead, let's take a look at the inactive host. So, like Luca said, this is the first time that in ntop-ng we have seen something that is not going to analyze only live traffic, but it is going to show you normal live traffic. In fact, again, in an enclosed system or even on your home network, you have that the same host, local host, are going to connect to the router, to the network itself. And at the same time, you have that some specific devices have to be always online, have to be always active. But in ntop-ng, before it was not possible to see if those hosts were active or not. Now, instead, we added this possibility to check um, which hosts are active in the standard host page and which local host instead currently it is no more active. In that way, and we added even some other information like first and last seen. In that way, it is possible to understand when an host disconnected from the network and why it happened. Instead, now let's jump to another ntop-ng change, a huge change that we did in the last period of time. We totally changed something about the user interface. And the first thing I want to talk you about is the time series and the charts itself. We decided to totally change, to totally rework again the charts. We changed the library that we were using before because we had many problems with that library. Not just, let's say, developer problems, but even as a user, there were a lot of problems. First of all, the performances, because many times it happened that in networks with a huge amount of data, so when we had, for example, to request for a month of data, we had many problems loading the page with performances because many times it needed something like 7, 8 seconds, 10 seconds just to load a simple chart. Other problems that we had were with the user experience itself. Uh, those charts were not really user friendly. And for this reason, we decided to rework those charts. We covered a lot the loading time from, for example, on my machine, I tried this last week, and I lowered the loading time from 4 to 5 seconds to below 1 second of loading. Other than this, it is a lot more responsive. So whenever you add the new time series in the page, if you remember, we have now the possibility to add multiple time series on the same page, and it is possible to see different charts, one for each time series or multiple in the same chart. It is a lot more responsive, and it is possible, for example, to zoom in and zoom out on the same time frame for each rows and so on. Uh, Let me jump directly to ntop-ng so that I can show you those things. And here we are, for example, in the interface, my lab interface, ntop-ng. And for example, here I have low traffic, but as you can see, still we have a lot of points. And if we change from, for example, the last 30 minutes, so the default time frame that usually the page loads to last week, as you can see, the loading of the time series is pretty much instant. And other than this, it is possible now, for example, we want to analyze a specific time frame. We want to analyze a specific time frame before you had to change the time frame by using this exact calendar. But what happens if we see from the chart here a specific time frame that we want to zoom in? Simply it is now you can simply drag and drop in that specific amount of time, and you are going to zoom in that amount of the time. And as you can see again, the performances are quite good now. And again, like before, you can add multiple charts. So for example, in the same time frame, we added the HTTP chart for the N01 interface, or we want to add even the SMP traffic, and so on. So other than the time series changes, what we changed are the tables. The tables, again, we were using a third-party library. This time we decided to develop our own tables. So let's say that they are homemade tables. We do not use a third-party library. And we decided to do this again for performances and user experience problems, because before the data tables we were using were pretty slow, and sometimes we had some problems with the visibility of the columns and the possibility to change what columns we wanted to see and so on. So we decided to change those tables by doing a total refactor, and now we have many new features. So we have, for example, the possibility to remove columns. We have the possibility to change lengths to the columns. We estimate the loading, and so let's jump again to ntop-ng to take a look directly at those changes. We still not imported all this new table in the whole ntop-ng, but this is what we are trying to do. Let's see, for example, in the alerts page, we added the new table in the alerts page. And as you can see, like I was saying, now it is possible, first of all, to change what columns you want to take a look at. For example, we are not interested in the pools, so we can simply remove the pools column from this table. And as you can see, there are no pools columns here. Other than that, we estimate a lot the loading of the table. As you can see, it is pretty much just loaded. And the most important thing it is that we can simply drag and drop and change the length of the columns. This is in order to have a better view of the information we want to display, because in many systems, many times some users are interested mostly in, for example, networks, or in the standard triplet, so the client server and the protocol. Other times, instead, some users are interested in the community ID. In this way, it is possible to customize your tables in the way you most like. So thanks everyone, and this is everything regarding ntop-ng. So Alfredo.
Yeah, let me share my screen. Can you see my presentation?
Yes, yes.
Thank you. So hi everyone, this is Alfredo. As introduced by Luca in the introduction, I will talk about three different items, three different new features that we added in the past weeks. So let's start with the first one, smart recording. So before talking about the smart recording, let's introduce it with talking about the continuous recording. So what is the continuous recording? So in most cases, when we want to access raw data for an event that happened in our network, so we want to get a pickup file, we have to continuously record the network traffic, because it's not possible to predict when this network event occurs. So we need like a 24/7 camera. We need to record all the time this traffic. And when something happens, we are able to go back in time and extract the data that we need. So capturing the traffic on demand is not an option, let's say. Now, if we want to implement the continuous recording, we have to pay attention to the data retention. The data retention is the amount of traffic that we're able to keep. So how long in time we can go back and get the data that we need. The data retention depends, of course, on the traffic speed and on the storage size. So if you consider, for instance, at a gigabit link, we have more than 1 gigabyte per second, worst case, if this link is really full, which is like 4 terabytes of data per hour and 100 terabytes per day. And if you consider a 100 gigabit link, this is even worse. So we have like 1 petabytes of data per day. So during the evolution of our ntop, which is our traffic recorder, we added more and more features to be able to let you save space and increase this data retention. For instance, we introduced the packet compression to compress the data on disk, and we have seen that this can save a lot on specific traffic like high frequency trading traffic, for instance, or LAN traffic. But on internet traffic, it doesn't compress much. It's like 5–10%. We introduced the packet slicing, so the ability to dump to disk not the whole packets with the payload, but just the headers. So you can specify you want to dump the headers up to the layer 3, layer 4, for instance. Or you can apply filtering, legacy filters like BPF filters, where you specify you want to dump traffic just for this IP and port, etc. But it's difficult to predict what traffic, based on these legacy filters, what traffic we should dump to disk. So it's usually difficult to use it unless we want to dump the traffic just for selected machines in our network. Then we introduced something better, which is the layer 7 filtering. So it's the ability to discard traffic based on the application protocol, because we know that there is traffic which is not really interesting or it's useless. For instance, encrypted traffic, compressed traffic. If you do an analysis, we do really little with this kind of traffic. So we can use ntop to discard and dump just the interesting traffic and discard, for instance, Netflix traffic, YouTube traffic, or shunt it. That means I dump just the first packets of each communication and discard all the remaining traffic. Now, what happens if the data retention, after applying all the techniques that we have seen to save space on disk, but what if this data retention is not yet enough? So we have been thinking about this, and we have realized that we can do better. So the assumption is that not all the traffic is the same. So for instance, there is traffic which is matching network events. We have seen that ntop has behavioral checks to detect if a node is misbehaving, for instance. And there is the rest of the traffic that probably is less important than the one which is matching network events. So what we need is to prioritize the traffic which is matching network events, alerts, for instance. And when we have to delete data on disk to make room for the new data, we should delete the data which is of less interest before. So this is what we call the smart data recycling. So delete the traffic which is not matching any events first, and then delete the events. So the idea is we want to implement this smart data retention, which has been actually implemented in the past months. So the idea is to process the network events generated by ntop and use 2 levels of storages. A first level of storage where we will implement the continuous recording, so where we dump all the traffic, and the second level storage where we will move
the pickup data, which is matching network events generated by ntop-ng. So let's see how it works. So let's start with the continuous recording. So the standard way of recording pickup data to disk. If you consider this timeline, at this point we start capturing the data. So we start filling the disk with traffic in pickup files. So more data is coming. At some point, the disk is full, so we reach the maximum data retention. So let's call this maximum window size. So it's the number of hours, for instance, that we can keep on disk. So this sliding windows is moving. So at some point we receive more data. We have to delete the oldest data to make room for the new one. So this sliding windows is moving ahead. An event is detected by ntop-ng, and we are able in ntop-ng to drill down and get the pickup traffic for the event. So we can download the pickup and analyze it with Wireshark. But what happens is that after, for instance, if we have seen that in gigabit, we have 4 terabytes of data per hour. So if we have a small storage, let's assume it's 4 terabytes. After 1 hour, the old data is deleted. So I lose the pickup traffic for this event. So I'm no longer able to drill down into ntop-ng and get the pickup data. Let's see instead what happens with the smart recording. In the smart recording, I have the same first level storage that in this case we call cache, where we continuously record the data. So we have this cache, which is where we dump the data. At some point, we get an event. We are able to drill down. But at the same time, we have this smart recording service, which is moving the data which is matching the event in a second level storage, which is the archive. So what happens is that more data is coming, and the data, the pickup data for the event is no longer in the cache, but it's still in the archive. So I'm still able to drill down into ntop-ng and get the pickup data from the archive. Now, this archive is also a sliding windows, has a data retention, of course, because the disk is a limited resource. But due to the fact that I'm moving to this archive only the traffic which is matching the events, this means that with the same disk space, I'm able to keep traffic data, pickup data for traffic matching events for a much longer period of time. If the cache is able to handle, for instance, 1 hour at 10 gigabit, probably with the archive, with the smart recording, I'm able to keep days of pickup data matching the network events. And again, of course, also the archive has a maximum window size depending on disk size, but this is much bigger. Now let's move to the second item, the IDS acceleration. So in this case, we wanted to run Suricata and Zeek or other IDSs at 100 gigabit. But we know that IDS systems are well known to be CPU intensive, or in general resource intensive. It can be also memory. So over the years, we tried to accelerate those systems in several ways. So we started making those systems PF-ring aware, so adding support for PF-ring in order to accelerate the packet capture. And this was using the CPU utilization, especially with the advent of the PF-ring zero copy drivers, for instance, using Intel adapters or the NVIDIA Connect-X adapters that we support today, you are able to accelerate those systems and improve the performance. Then we introduced also the layer 7 acceleration. That means that you can use our PF-ring FT to discard traffic which is useless, let's say, for an NDS, and that if you consider internet traffic, it's actually most of the traffic. So if you're able to discard traffic which is, for instance, encrypted or compressed, like TLS, or multimedia traffic like Netflix, YouTube, or Spotify, you are discarding 70% of the traffic, 80% of the traffic, and you're saving a lot of resources like CPU when processing this traffic in the IDS. But again, with the similar idea of the smart recording, we decided that we have been thinking to this, and we realized that we can do better. So the idea is to run Suricat and Zik, let's say, on demand. So the idea behind this is that we can just discard all the traffic by default and send to the IDS only the traffic which is interesting. That means that we send to the IDS only the traffic which is about misbehaving hosts, for instance. So how to do this? The idea is to send the traffic, instead of processing this traffic, the whole traffic in the IDS itself, we process the traffic using ntop ng directly or through CentOS. For instance, if we have 100 gigabit of traffic, we probably want to use CentOS, which is able to keep up with 100 gigabit, and which is sending traffic information to ntop ng, so flow metadata. ntop ng is able to export event about misbehaving hosts, so it's able to send events like ban this host or unban this host. And this is done using a Redis queue. In PFRing, we introduce what we call the runtime filtering. So the ability to push filters to the adapters on the fly. So we have ntop ng, which is telling PFRing, hey, there is this host which is misbehaving, requires attention, and I want to analyze the traffic for this specific host using the IDS. So another rule is pushed to the adapter, and the adapter is sending this traffic to the IDS. So the IDS is processing only selected traffic, a really small subset of the traffic. And this way, we are able to scale and process traffic up to 100 gigabit per second. And again, in this case, we have both the visibility with ntop ng and the IDS analysis at the same time. Now, the last item I want to discuss is the new cloud license. Let's see what is the problem that this license is trying to solve. Now, if we have ntop ng in a centralized place that can be on the cloud, which is receiving traffic information, so flows from a remote probe, because we have a remote location, maybe you have ntop ng in the cloud, and we have a probe on premises, or we have a distributed network with many probes, where those probes can process packets coming from a spam port or a tap, or can process flows coming from routers and switches, like using NetFlow or IPFix or SFlow. In those cases, what I need to deploy this is, of course, to install ntop ng on my centralized place and probe on the remote location. And then I have to generate a license for ntop ng and a license for mprobe. Now, if I have just a single place to monitor, probably this is fine. But if I have a distributed network with many probes, that means that I have to generate a different license for each probe and install it, of course. Then probably I run and probe on a container. This container dies. I have to recreate the container, and then I have to generate a new license. This is really annoying. Not to mention that if you're running this over internet, you probably want also to encrypt the data. So you configure ntop ng with a private key. ntop ng generates a public key, and you install this public key on all the probes. So this is why we introduced the cloud license. With this license, all you need to do is to generate a license for the machine running ntop ng, and that's it. So you don't need a license which is per probe. So you don't need to bother with system IDs for all the machines or containers or virtual machines running in probe, and generate a license for each of them. The only thing that you have to do is to get a key that is generated by ntop ng, which is the same for all the probes, and distribute this to the probes. This is, of course, to encrypt the data because you are over the internet. and this is mandatory in this case. So let's say that this topology is secure by design because this requires this public key that you distribute to the probes. But again, this is the same for the probes. You don't have to bother with the system ID, or if a container dies, you don't have to get the system ID for the new container, generate a new license, etc., etc. So you probably know that we already had a bundle license. So what's the difference between the bundle license and the cloud license? The bundle license has been designed to address a different problem. This has been designed in case you have to run ntop-ng and then probe or into disk on the same box. So in this case, you generate a single license for a good price, and you with a single license, you unlock all the softwares. Instead, this cloud license is trying to address a different issue. So this is trying to address the issue of the deployment. So this is used to automatically unlock all the remote probes that connects to the centralized ntop-ng. In fact, this has been designed for service providers, for instance. If there is a service provider that wants to provide this monitoring service, so they have this ntop-ng with the license on site in the cloud, and they distribute the probes that can be a container with the public key pre-installed. I don't have to bother with the system IDs. This is a new feature. This has been already implemented. So if there is any one of you which is a service provider or that wants to provide a cloud service and is interested in an early adoption, just contact us. So this was the last item. Let me just remember you about what Luca already said during the introduction. So we are organizing again the conference this year in Pisa, the ntop conf. And this will be 21, 22 of September. And if you want to submit a talk, you're really welcome. And the deadline for this is end of June. So if any one of you has some question, please raise your hand and let us know.
Alfredo, I answered many questions, but there is just one that I don't know if you're able to show how to set up alert export over syslog.
Okay. Let me see if I have a running instance.
So if it's complicated, I can do it.
Yeah, maybe we should do this offline because yeah, it's a bit long for the webinar, I think. Yeah, I think that it's better if you contact me by mail and we can schedule a call and I will guide you through the configuration.
Okay, let's answer all the questions. Then we should. There is a new question. Buta, do you want to talk? Please open your mic.
Hello, can you hear me?
Yes.
Yes.
I have one question asked you to show the license here for the cloud, only for the service provider. But for us, it's in the execution, but we have multiple locations. Is it possible that the execution can get the cloud license?
I'm sorry, but I cannot hear you.
Okay, let me repeat again.
Okay, now I'm better.
I saw the cloud license. It is possible to transfer the probe from another location or from another, let's say, a data center, because as for us, we are the institute or education. We have multiple locations. Let's say one is in the province and another one is in another province. So is it possible for the education can get the cloud license?
Yeah, technically, this is the problem that this license is trying to solve. So yes, the answer is you can move the probe. Now, as the target is a service provider. I mean, we have been designing this for service providers, but we can discuss about deploying this in your environment.
Okay, and another one is relating to the license. For the professional license, normally when we do the reinstallation for the physical machine, we need to request the new license. We call the system ID exchange. So are there any way that we can still use the existing license without request to you again or not?
If you're just reinstalling the machine without changing the other configuration, then you don't need to generate a new license. You can use the same. So you have just to keep aside your license key and restore it. If you change the other configuration, then you have to migrate the license to the new system identifier, let's say. So in this case, you have to go on our website and regenerate the license. And you're allowed to do this one time, unless there is a special case and you can contact us.
Yes, it is hard because for us sometimes the machine, because we use the physical machine to capture the traffic, and mostly there is a problem with the hard disk. It crashed because already there is too many data that sent to it, so hard disk crash. We put a new hard disk, and then okay, the license need to be generated, and then we need to ask you, and as you have mentioned, the policy is only allow for one time only for request. That's why I am asking if there is any way that we can reuse the old license or not. But in case if there is not, then we need to request to use it.
Yeah, that's the point. Yeah, let's please drop us an email with your specific case, and we will see how to handle that.
Sure. Thank you so much for this. So basically, it was a nice presentation for this one. Okay, thank you. You can continue.
Thank you. Anyone else? Other questions?
Alfredo, if you leave me the stage, I can show the syslog and answer the other question.
Ah, you have it. Okay, great. Thank you.
So in essence, the question that is on the chat is the following. How can I deliver alerts, not flows, alerts to a remote end through syslog? So what you have to do here, you have to go to the notification menu here, and then you see this page and the points that are recipient. If you click on a plus, okay, you will see several ways of delivering alerts, okay? So Mattermost, Freight1, Elastic, whatever. So we're talking about syslog. So you select the syslog, okay? You specify a name, let's say my syslog. Okay? And you have to specify the host to which you want to deliver these alerts, 192, 158, 1.2, things like that, okay? And then you do add. This one is configured, okay, but no recipient is configured. So it means that we configured the endpoint, the syslog endpoint, but nobody will be receiving it until you do that. So you click on this link, no recipient, okay, and you click on a plus button, and you see that it shows you immediately the one that we have just created. Let's say, deliver alerts to syslog. Okay, and you specify what to deliver. So all the alerts are only with a certain minimum severity. Okay, because this is very important, because sometimes people contact us, say that they have drops in alerts, but because alerts can be anything. Okay, even a notice, somebody that has receiving something that is not perfect, but is not too bad. So we suggest to send something at least of error warning, let's say. So you can specify what category. So if you want to say, I want to receive alerts only for SNMP, okay, you can deselect everything except this one. You can specify what type of entity. Let's say I want to receive alerts only of flows or MAC addresses. And then you specify, okay, this is basically default. You can set all, and you say add. Once you've added it, for every alert here, you will see the number increasing, and you see that those events, okay, are delivered through syslog, in addition to the internal database that is used for showing you the alerts in the user interface. So in essence, in the Alert Explorer. So this is very simple. I hope I answered your question. Any other question? I think we are good. Today we had enough questions. We remind you that you can contact us at any time on Discord or Telegram in addition to email. If you go to the ntop website, we have the community support. Thank you very much for being here today. We record this presentation, upload it to YouTube, and put the link on the blog page. Thank you very much again.
Thank you, everyone. Bye-bye.
Bye-bye.
Thank you. Bye.
Thank you. Bye.
Bye.